This is our second dividing lesson, but it's actually the third video. So if you haven't gone and watched the video where I go through the difference between grouping and sharing using Lego, can you go back and watch that one before you watch this one? Right, I'll assume everybody's watched that now. So today we're going to learn to divide by grouping on a number line. So what we did in that last video with the Lego might have seemed quite simple, because that was because it was leading to this. Now this also might seem simple to begin with, and I might be solving divisions on this using a number line that you can do in your head without a number line, and you might be thinking, well, why are we doing this? What is the point? The point is we're then going to move on to larger numbers that you can't necessarily do in your head without a number line or a written method. This is in the middle. We've done in our head, but only up to as big as our tables go. We're going to do on a number line today, but past where our tables finish, and then we're going to move that on later in the week, or possibly next week, into more compact and more efficient written methods that are purely on paper, but take us into much, much larger numbers. Okay, so let's have a look at one of the questions from when I had the Lego out. Well, first of all, let's get some language sorted first. Like when we were talking about multiplications and we talked about factors and products, all the parts of this have got names. This first number is a dividend. And it's how many of the things we've got. In this case, it's how many Lego bricks I've got in total here. This number here is the divisor. In this case, it's how many we want to have in each group, because we're doing grouping. If we were sharing, it would be how many people we have or how many things we're sharing between. But because we're doing grouping, this is how many groups. So how many in each group? In each group. This is our total amount. And then finally, our answer that's going to go in here is the quotient. Quotient, okay? Which in our case is how many groups can we actually make? So how many groups? Now I'm sure you all know what 10 divided by 2 is, but let me just go through it just so you can see my train of thought. 10 divided by 2 in this case does not mean 10 shared between two people. It means 10 split into groups of 2. There's a group of 2, 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 there's a group of 2. How many groups of 2 have we got? We have got 5 groups of 2. We could use this for a question such as 2 people can fit on a bike. We've got 10 people. How many bikes do we need? We'd need 5 bikes. It could be people need to have 2 burgers to be nice and full. We've got 10 burgers. How many people can we give burgers to? 5, that kind of thing. So far, so very Lego. So let's turn this into a number line. Well, let's just draw a number line over it. Zeros here, and then we had 2 blocks, and then we had 4 blocks, and 6 blocks, and 8 blocks, and finally we got to the full 10 Lego blocks that I was using. Let's use a darker pen. I did one jump of 2, and then I did another jump of 2, which was 2, and another 2, and then I did another jump of 2, that was 2, and then I did another jump of 2, one jump of 2, that was 2, and finally I did another jump of 2, that was 2. I did 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps. I'm counting the jumps. I am counting these sort of lump jump type things. I'm counting the groups. I don't need the blocks in there at all. I can just have a number line. 10 divided by 2 is 5 because I need 5 jumps of 2 to get to the number 10. So let's do some other ones. How many jumps of 4 do I need to get to 36? Now, it depends being on how good your times tables knowledge is. You might want, and how good you are at counting in these numbers, more to the point, you may want to write out the times table along the top. So you might be sitting there going, well, perhaps my 4s aren't brilliant. So I'm going to sit here and I'm going to write out all of these 4s. So I'm going to put 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, and 48. And that's all my 4 times tables. Okay, so I need to keep on drawing groups until I get to 36. My first group, and I'm not going to draw the Lego bits in, I'm just going to draw the jump. My first jump of 4 gets me to 4. My second jump of 4 gets me to 8. The next one gets me to 12. The next one gets me to 16, then to 20, then to 24, then to 28, then to 32, and then finally it gets me to 36. You don't need to draw this 1 times 4 in, 1 times 4 in, 1 times 4 in, not yet, but I'm doing it for a reason that will come apparent in a minute. So how many jumps did I do? I did 1, 2, 3, 4, 5, 6, 7, 8, 9 jumps. 36 divided by 4 is 9. How many groups of 4 can I make when I've got 36 things? I can make 9 groups of 4. I can jump 4 times. I can check this by doing 9 times 4 and checking that it is 32. And if you use a trick with your fingers, you will know that 9 times 4 is 36, not 32. Okay, let's try another one. 56 divided by 7. Again, I've written 7 times tables out in case it's a tricky times table. 1 jump will get me to 7. 2 jumps will get me to 14. 3 jumps will get me to 21. 4 jumps will get me to 28. 5 jumps will get me to 35. 6 jumps will get me to 42. 7 jumps will get me to 49. And 8 jumps will get me to 56. 7, 14, 21, 28, 35, 42, 49, 56. And I did 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps, 6 jumps, 7 jumps, 8 jumps. 8 groups of 7. Okay. But what if the times tables are, the numbers are bigger than our times tables, which is kind of the point of this lesson. If you know your 7 times tables, you'll know the one that's got the answer 56, so you probably didn't need to do this. But numbers get bigger than tables. What about 68 divided by 4? Well, I can do this. I can still go to bigger numbers because I can just keep on adding 4. Now I can write out 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60, 64, 68. That's a lot of jumps. I certainly can't be bothered to write all the numbers in between. I actually can't even be bothered to count it. Well, I don't need to. Let's be honest about this. Let's be a bit clever about it, actually. Let's try and find another way of writing this down. Rather than drawing all of the 1 jumps, I'm going to say to myself, well, how about if I draw 10 jumps in one go? I'm going to do a big jump, and I'm going to label it 10 jumps of 4. 10 times 4, well, that gets me to 40. Can I get from 40 to 68? Well, what is the jump from 40 to 68? That gives me another, what's that, 28? Well, how many 4s are there in 28? 4, 8, 12, 16, 20, 24, 28. That's 7 4s. 7 jumps of 4. I didn't write out all the individual jumps. It would have taken me too long. That jumped me 40. This jumped me 28. So how many jumps did I do in total? I did 17 jumps. 17 groups of 4 in 68. Let's try 78 divided by 3. Again, I'm not going to draw out all the little jumps, it will take me ages. So let's just do 10 times 3. 10 groups of 3, that's 30. Well, nowhere near 78 yet. Do you know what? I could do another 10 times 3 and I still wouldn't have gone too far. So let's do that. Another 10 jumps of 3, that's 30. That gets me to 60. I'm getting quite close now. I need to get from 60 to 78. Well, that's 18. Well, how many 3's get me to 18? 3, 6, 9, 12, 15, 18. It's 6. That's 6 jumps of 3. So I did 10 jumps. Another 10 jumps, that's 20. And 6 jumps, that's 26. So even though I don't know my 3 times tables up to 78, because I know them up to 10 and up to 10 and up to 6, I was able to piece it together using the number line to help me keep track as I'm going along. Last one, 99, big number. We can go much larger. In fact, is it the last one? No, I've got one more after this. 10 3's, that's 30. I can do another 10 3's. That's 60. Oh no, that's still 30. It gets me to 60. I could do another 10 3's. Another 30, that gets me to 90. Now I've only get from 90 to 99. Well, that's 9 more. How many 3's make 9? Well, 3 3's make 9. 3 3's. So I jumped 10, 20, 30, and 3. 33. 33 jumps. Now, some of you might look at that and go, oh, what about if I jumped 3 jumps of 11? That would have got me straight to 99. Well, that would work. It's another option. You haven't got to use 10 times. I just think it's a nice easy number because we all know our 10 times tables. And it's useful when we move on to written methods. So last one, let's do a 3-digit number. Nothing stopping us doing a 3-digit number. Our number line goes on forever, and 7s is quite big. We'll get there quite big, quite quickly. So let's do a big jump of 10 lots of 7s. That's a jump of 70. Gets me to 70. Well, I'm nowhere near 161 yet. So let's do another big jump of 10 lots of 7. It's another 70. Well, what are 2 70s? It's like 2 7s, which is 14, but it's 10 times bigger. So everything moved to the left, and in goes my placeholder 0. I can't do another 70. That's just too far. So I need to get from 140 to 161. Okay, 140, 150, 160, 20, and another one, 21. I need to get 21 more out of this jump. Okay, well, how many 7s make 21? Well, hang on a minute, that's 3, isn't it? 3 7s, 7, 14, 21, yeah. 3 jumps of 7. So I jumped 10, and another 10, and another 3. I jumped 23. So the fact that's a 3-digit number, that didn't make it particularly difficult. In fact, if you'd have known that 20 times 7 was 140, you could have just done one big 140 jump here, and there wouldn't have been a problem. So, battery's low. I'm going to leave that there for today. My original plan, and the first time I recorded this, I went on and did remainders all in one go, and it turned into a massive, great big long video. And you've already just watched a Lego one, so let's stop now. I will give you 2 sets of calculations, some that are dividing within your times tables, so the ones that you could do within your head if you knew your times tables brilliantly, but I want you to draw them out for the sake of it. And then the second set I will give you will be numbers that are much bigger than your times tables, so that you can go and you can use this method for what it's actually designed for, which is doing the bigger numbers. And then I think the third thing I'll do is I'll give you some worded questions. Worded questions that are all to do with grouping, not sharing, but grouping. Remember, If I give you a worded question, I would like a worded answer. If I give you a written question, a number sentence, I want the answer written down, not just an underline in the working. And what I want more than anything else is the actual number lines drawn. I do not want to see a load of answers in your book with absolutely no working. For the easier ones, you might not need the number line, but we're doing this to see that you can do the number line. So skipping that bit out makes it pointless. For the larger numbers, to do it without a number line, that's just suspicious. Okay, so every question you do needs to have a number line drawn with the jumps that you've used drawn on it and the answer written out. Okay, any questions? Just send one of us a message.